Hello, I'm Tom Hollingsworth, and welcome to Networking Field Day. We are here in Palo Alto, California, with our friends from Apstra. We are going to be listening in about their new product and solution, and we have around the table a group of Networking Field Day delegates. They represent the best and brightest podcasters, speakers, writers, and influencers in the community. They are going to be asking questions, making comments, and offering their opinions as part of an invited panel. If you would like to learn more about this event, including how to become one of these delegates or a presenter, please go to our website at techfieldday.com. You can also find more videos like this about a variety of technical subjects at our YouTube channel, which is at youtube.com/techfieldday.
What I'm going to do is I'm going to show you what I like to think of situational awareness for a running network. So as Derek said, what we have is a deployed, we'll call it a pod, for a data center. And what we can see immediately from this is what devices are under management. So, and I'll explain what that means. But here we have 2 spines and 2 leaves. And in this particular deployment, we have 3 servers under management as well. And so when somebody says, hey, is the network ready for business? You know, you can look at kind of a heads-up display, like an Iron Man heads-up display, and say, yeah, this is good. I mean, it looks good to me. But if you wanted to see all aspects of the telemetry, you know, we get the contextual information that really makes up the service of this pod. When we say, well, what is this network or what is this service? We're deploying a spine leaf in a layer 3 clause type of arrangement, which is kind of a common architecture that people in data centers want to deploy. And when we talk about context, we're breaking it into the specific pieces of the service. We can say, for example, the IP fabric, the spines and the leaves, what makes up that service? We can see that we have expectations about the BGP neighbors that connect between all of the leaves and spines. We have expectation about how the cabling should be. You know, are the ports plugged into the right place? Because surprisingly, if you get something plugged in the wrong place, it has this incredible blast radius of a problem effect. And I'm going to show you that through our product. And then having information, of course, about the interfaces, whether or not those interfaces are up or not. And we go through each of these segments of a service. Now, in this case, it's a layer 2 clause service. But conceptually, you know, this could be any type of network service. We started with a layer 2 clause and data center because a lot of people wanted to do that. But the platform technology of AOS is adaptable for just about any kind of network application you want to use. But as Derek said, in version 1 of our product, we have focused into the data center layer 2 clause type of application. We also have information about what this pod is connecting to. We talk about that as this is our external router or our external routing. You know, how is the relationship between the pod and the external router acting? Are the BGP sessions proper? Are they up and running, and is the interfaces up and running? And when we also have the routing verification, so imagine that you've deployed this configuration and you want to make sure, is all my routing tables correct? Imagine all the commands that you have to type to say, are the routes in the places that I believe them to be? Because we know, or we have an expectation of how this service should be deployed and all the routes where they should show up, we can validate that all the time in a continuous basis. It's like having CCIEs on all of these boxes, constantly typing show commands and reporting the information back against what they know the service should be. So we're doing all of these validation checks all the time in a continuous basis, and we're comparing the results of all this data to the expected value to report whether or not something's wrong. So I'm going to show you what something wrong looks like. Like, let's say that we swapped some cables. Like, we made something bad happen here, right? Now, go ahead.
Oh, I thought you were going to swap cables.
Well, I'm going to show them the link validation. The link validation really gives us, really nice insight into what is going on a device basis. So let's say that I was cabling up, like my spine 1, and I've got 2 leaves that it's connected to. I can see that right away what this is representing is the interfaces are up, which is the green blocks, that I've got a valid connection between them, and that is the proper and correct cable validation, right? We know that it's cabled properly. I'm going to swap two cables, and I'm going to get close to some noisy equipment while I do that for a second.
So we actually have, the way AOS actually works, sort of from a, if you were to put it in your environment, there's an AOS server, and then there's actually agents that go onto the supported hardware platforms that we support. And these agents do different things. There is a configuration agent. There's also a telemetry agent that continuously scrapes information off the box and then streams it off box to the server. Then the server, in turn, can be configured to stream information anywhere you want it to go, like InfluxDB, Grafana, whatever tool you like to use. And the cool thing about that is that there is no SNMP here. For a network that's being run by AOS, there is no SNMP.
So I can show you that from a simple, I've swapped two cables, and what I wanted to show you is kind of the blast radius of that effect. If somebody was just looking at interface information, they would see, well, the interfaces are up. But as a result of having a cable swap, I have BGP sessions that are down. And as a result of those BGP sessions are down, I've got routing problems. So you might get a phone call that just says, hey, my app is running weird, it's slow. Can you figure out why my app is slow? And if you didn't have this kind of insight, you might be like, oh, let me troubleshoot the BGP session. Oh, the BGP session is down. Well, the interface is up, and I'm going to ping this, and that works. And you could be trying to troubleshoot this problem for a long period of time. And your mean time to insight is drawn out, which means your service is down for a while. So your network isn't what you expected it to be. It is not the network that you want. But you can see, kind of from this, and this is, again, 1.0 heads-up display. Imagine, the Iron Man suit, Mark I. It was pretty clunky, but the next iteration gets shinier and better, and we're going to show you a little bit of sneak peek at the end. But even this shows you, I've got a cabling problem, and looking at the link validation, we can see, look, these two cables are swapped. And even if you made this page available to a facilities engineer, they would know that, hey, I've got these two cables swapped, right? There isn't, hey, Mr. NOC engineer, get on the console and do a bunch of show commands, and is it cabled to the right place? And you're looking at a spreadsheet to see if it's cabled to the right place, and that spreadsheet may be valid. It may be an old copy of a spreadsheet that somebody copied, and that disaster never happens at 3 in the morning.
Yeah.
And it's like, look, it's a cabling problem. Swap it back.
But the cable swap is really cool because it wouldn't know if the cables were swapped unless it had context for that, for realizing that, right? It has to know something about the way the network is supposed to be in order to determine that the cables were swapped.
So you can see, like, when I pulled out the cables, we get interface alarm errors because I pulled out the cables. Now the interface alarm errors go away, and I'm left with cabling errors, or what we'd call anomalies. Not really errors or anomalies. They don't meet our expectation. And if I were to look at what these expectations are, I can see what's going on. Well, I expect to see switch port 51 on leaf 1, and I actually don't see anything right now. That's because LLDP, slow protocol, it's converging. As a network engineer, that's reasonable, right? Again, we're building technology for network engineers to augment their capabilities, to give them, what I like to consider superhuman powers. We're not replacing engineers. That's, a lot of people worry about automation is going to make them lose their jobs. It's quite the opposite. It's this type of technology that will help you do things you never thought possible, or at least, not have to be in a knock at 3 in the morning on a Saturday when you'd rather be at your child's birthday party. So I'm going to go through and kind of show you a little bit more detail about the kind of telemetry or the kind of insight that you get in our system. We can go into any one of these nodes, say spine 1, and here we have all the types of service-oriented information relative to this network pod that we're monitoring or managing. And by monitoring and managing, I mean that AOS builds the configuration for these devices. It applies that configuration for you. It makes sure that the configuration is on the box and running. And then we start collecting the telemetry relative to that configuration. So it's this holistic picture that Derek has drawn up there. And we're going to go through that whole process in a lot more detail. From we're going to burn this to the ground, and we're going to start from scratch together. I'll show you exactly how you can build a data center from scratch in front of you with real hardware. We'll do that in kind of the second part. But here we can see that these are all of the BGP sessions that make up this service because we're doing BGP peering on these interfaces. We know all of the information from IP addresses and ASNs, all the information that would help you troubleshoot a problem. We give you all the LLDP information, and I can zoom in so you guys can see this a little bit better. So you can see exactly, in this case, we expect certain things. We see what they actually are. We provide you the system description from the remote side. Of course, we'll give you interface telemetry, meaning we'll show you that these are interfaces we expect to be up, and they are up. But imagine you're doing some kind of maintenance operation, and you need to take an interface down, and that's an expected state, right? So when you're doing a maintenance operation, you need to take something down. It's not an anomaly if you expect the network to have that state. Of course, interface counters, and then config deviation. People ask us, well, what happens if somebody gets on the box and makes a configuration change? Can you detect and report that? And I'm going to show you a very specific demonstration of that in just a second. So again, I think that the telemetry aspect or the operational detailing is really 70% of the problem when you deploy and manage a network. Building and deploying an initial network service is hard. Especially in a multi-vendor environment, it's very hard to get right. You can build the configs, you can push them, you can validate them, but it's the day two operations of monitoring and troubleshooting and managing it. And that disconnect, that network blindness that people have, if they don't know what it should be, how do they know that it's right? And when you have a NOC team that doesn't have that awareness, they end up calling somebody who has to look at configs and reverse engineer it in their head, and they're essentially creating this very complex relationship in your mind. That's what the network engineer is doing. It's incredibly hard what network engineers do when you think about it. It's a distributed systems problem. They're doing all this information traversal. It's mind-blowing. And this is a very simple case. This is a simplified network that says layer 2 or two-stage layer 3 cloths, minimal protocols, just BGP and LLDP. Imagine really complicated systems. So before I go into the next part of this demo, would you like to add anything? Or?
So, are you going to do the vendor swap next?
Yeah.
Yeah, so let's say a switch goes bad in your environment, right? So it just, something goes wrong with it and you got to replace it. And you have it in a closet somewhere, right? The new switch is in a closet somewhere. And you pull it out and, what are all the things you have to do to get that switch into that rack to replace the other switch? Well, you got to get the right version of code on there, right? Whatever network operating system it is. You have to get, the management plane, the control plane. You have to basically configure, the whole thing, shove it in there, turn it on, and then you start validating that it's working as expected. And it could be a slightly different model than the one that was in there. And if, assuming you didn't, and if you didn't put the right network operating system in before you put it in the rack because you weren't thinking about it, it might not actually have the features you need to run, right? And that could be problematic. And in any case, you're going to be in the CLI of the old switch and the new switch, trying to figure out exactly how it is you're going to get this done, right? You're going to come up with a plan, and it's all driven by what you see and do in the CLI. So that problem becomes, an order of magnitude harder if it's a totally different vendor, right? Because now you got to think in terms of translating the config from the old one to the new one. And it's true that they're all similar and they're running the same protocols and all that stuff. But if you've been in networking long enough and you've worked with many vendors, and you know that different vendors have different default settings and slightly different keywords in different places. And if you're not thinking about that and you're doing this swap, you're going to make a mistake and you're going to cause an outage or, whatever. You're going to make someone really mad, like the server guy or some Java monkey, and he's going to start swinging hammers.